Over the past 15 years, Kaggle has evolved into much more than just a competition platform. It's become a thriving global community of data scientists, machine learning engineers, and researchers, all collaborating in the open pursuit of AI excellence. From public notebooks and insightful discussions to cutting-edge models and reproducible pipelines, Kaggle has grown into a living archive of collective intelligence and innovation. This write-up reflects on that journey, a celebration of the Kaggle community's role in shaping the modern AI landscape by analyzing the meta-Kaggle and meta-Kaggle code datasets that chronicle the platform's public contributions over time. We uncover how thousands of individuals across the world have influenced trends in tools, techniques, and technologies. But this isn't about leaderboard scores. It's about the code, the packages, the functions, the tools, the very language of modern data science. We'll spotlight the individuals and countries who were the first to adopt key methods. We'll track the rise of AI-centric libraries, and we'll witness how public coding on Kaggle has transformed through the years. This is a story not just about competitions, but about collaboration. Not just about artificial intelligence, but about the people behind it. The Kagglers, whose curiosity, generosity, and determination have pushed the boundaries of what machine learning can achieve. Now here's a quick disclaimer. All insights in this write-up are based on those 1.1 million notebooks. It's entirely possible that some early code, or edge cases, may not be reflected here. But that doesn't take away from what we're about to uncover. So, without further delay, welcome to the write-up from Team CodeArchaeologist. I'm Ayush, honored to present this journey to you today. Tighten your headphones. Turn up the volume just a bit. Grab a cup of coffee, and get ready to travel through the history of Kaggle, one notebook at a time. Ready? Let's get into it. Alright, before we dive into the depths, here are the key highlights from our analysis. Think of this as your map of the journey ahead. First up, the stats. We'll explore some simple but powerful numbers about how Kagglers have contributed to code over the past 10 years. From cells to comments to entire notebooks, the scale is mind-blowing. Next, the trends. What has the timeline of code write-ups looked like? When did activity spike? And what major events in the AI world may have caused it? Then, we meet the titans, the top Kagglers who've written the most code on the platform. These folks aren't just prolific, they helped define what Kaggle coding looks like today. After that, the nations. We'll take a look at the top countries contributing to Kaggle code. Which parts of the world are leading the charge in community-driven AI? Now here's where it gets exciting. We tracked down the first Kagglers to ever use some of the most iconic functions, packages, and methods. Yup, we found the pioneers, the early adopters. The ones who said import before anyone else even knew it was cool. And finally, a shout-out. A tribute to the OGs of Kaggle. The silent warriors who didn't just code. They inspired others to learn, experiment, and build. This one's for them. Let's unpack it all, one section at a time. Alright, let's talk about something incredible. The pulse of the Kaggle community. These notebooks? They're not just code. They're conversations, experiments, and honestly, a piece of history. Over the years, Kagglers have built what might just be one of the largest public codebases in the world. And when I looked at the numbers, wow, it's like watching the internet write a textbook on AI. Let me hit you with a few highlights, just 5, that blew my mind. First up, over 888 million notebook views. That's almost a billion people clicking, reading, learning from each other. It's not just code. It's Kaggle's own open-source university. Second, the community has written over 219 million lines of code. That's not just impressive. That's practically rewriting the Python docs from scratch, multiple times. Third, did you know that Kaggle notebooks contain over 1.16 billion words? And it's not just code, markdowns, explanations, storytelling. We're not just modeling. We're documenting our thought process, like digital scientists. Fourth, there are now over 1.18 million notebooks available. That's 1.18 million chances to learn from someone else's approach, someone else's curiosity. And finally, over 34,000 packages have been used. That means we're not just reusing the same old stuff. We're experimenting, we're evolving, we're innovating. So yeah, Kaggle isn't just a platform where people build models. It's a place where people build knowledge, together. And every notebook? It's a tiny chapter in the bigger story of AI. Now, let's talk about time. What does the timeline say about how Kagglers contributed code over the years? Take a look at the graph. Some trends just jump out at you, and honestly, they tell a deeper story than numbers ever could. The first major spike? That happened between April and October 2017. Right around the time when deep learning was on the rise. And models like transformers were just stepping into the spotlight. Fast forward to early 2021. From January to June, we saw another wave of steady growth. Why? Think about the world at that time. COVID-19 was still at its peak, and many Kagglers were stuck at home. But they were also diving into medical datasets, building healthcare models, and tackling pandemic-related challenges. But the biggest spike? That came between April 2023 and January 2024. This was the era of generative AI. LLMs, advanced NLP tools, and the buzz around AI reached a new level. Kagglers were all in, experimenting, building, innovating. Now, here's something interesting I've noticed personally. Even though public notebook activity slowed a little after that, people didn't stop coding. They just went quiet. With tools like Kaggle Hub and the rising compute requirements, a lot of folks are now working silently, grinding, experimenting offline, and still winning competitions. The fire's still there, it's just more underground now. Between January and April 2022, there was another noticeable spike. Hard to explain exactly why, but a big part of it could be the post-lockdown effect. People were still indoors, still curious. And Kaggle became a creative outlet again. From there on, code contributions kept rising. And what fueled it? One word: LLMs. Open-source AI tools became more accessible. Models could now run directly inside notebooks. Curiosity turned into code. And that sparked a whole new wave of Kaggle exploration. This timeline doesn't just reflect numbers. It reflects mindset shifts. From pandemic-driven curiosity to quiet innovation to the explosion of generative AI, Kagglers have consistently adapted, evolved, and continued to write history, one notebook at a time. Alright, let's talk Kaggle legends. You see this leaderboard? The top spot in the notebook domain goes to none other than Kerneler. Yeah, the name says it all. He's a kerneler in every sense. Right behind him, we've got two human powerhouses, Spatici and Pwoke, forming a trio of data-wielding titans. But here's the kicker. Kerneler has written 5 to 6 times more code than the others. That's not just dedication. That's bot-level consistency. Oh wait, he is a bot. Yup. An AI bot created by Kaggle. His job? Writing notebooks to explore datasets. And honestly, he's doing it better than most of us ever could. Based in Sunnyvale, California, Kerneler has been around for 6 years, and even though he hasn't been seen in a while, his legacy lives on in millions of lines of code. Coming in second, Spatici, from Kobe, Japan. And yes, this one's definitely human. He's deep into LLM fine-tuning using RL methods. Has earned over 240 notebook medals and holds master status. One of the most consistent, high-quality contributors on Kaggle. Respect. In third, a truly inspiring story, Mpoque, from Brazil. Real name, Dr. Marilia Prata. Former dental surgeon, now Kaggle Grandmaster. I mean, come on. That's a level-up arc right there. She's got medals in datasets, notebooks, and discussions. She even mentions loving CSI and the Big Bang Theory in her profile. Because why not sprinkle in a bit of fun? And hey, let's not stop at 3. Shout out to 2 more incredible Kagglers climbing their way up the charts. Gurabdatakiat and Alexander K. Arabidopsis Thalian, Divray, YWK 8816, Wangjian, and Tusungeo. 5 more silent legends turning data into gold, one clean notebook at a time. You're in the top ranks of millions. That's no small feat. So whether it's a bot with infinite stamina, or a dentist turned data queen, or a baseline king, these are the people shaping Kaggle's notebook culture. And that's the beauty of Kaggle. Anyone, from anywhere, can become a legend here. We all come from different countries, and we're proud of our roots. But have you ever wondered which countries contribute the most code on Kaggle? Here's what the data says. India, leading the chart by a wide margin. Possibly a population effect, but there's no denying, Indian Kagglers are everywhere, writing, sharing, innovating. United States, always strong, thanks to early adoption and a deep tech ecosystem. Egypt, surprise. Egyptian Kagglers are climbing fast and making their mark. Brazil, bringing serious energy from South America. Japan, quiet, focused, and consistent. If we ranked by quality per user, Japan might just take the crown. Rounding out the top 10. United Kingdom, Russia, China, Pakistan, Turkey. Fun fact, India shows nearly 40% more code contributions than the US. But remember, this is based on total volume. If we measured average contributions per user, countries like Japan or the US could easily lead. In the end, this isn't a race. It's a reminder that Kaggle is a global classroom, where knowledge has no borders. ETs talk about what powers most Kaggle notebooks under the hood. The packages, functions, methods, and attributes. The true workhorses of the data science process. First up, the libraries. As expected, it's the usual dream team. NumPy, Pandas, Matplotlib, Seaborn, Sklern, and of course, Spoost. But here's what caught my eye, CV2. Yup. That means computer vision still holds strong in Kaggle notebooks. Even with all the buzz around NLP, CV's raw usage is still dominating. We also saw plenty of light GBM, Keras, and various neural network utilities. A clear sign that Kaggle is still very much in its ML golden era. Now let's look at the most used functions and classes. You probably guessed it, it's all the classics. Train_test_split, standard scalar, accuracy_score. Confusion_matrix, classification_report. And of course, good old random forest classifier. Still a crowd favorite, because hey, sometimes you just need a forest that works. Evergreen tree. And fun fact. Precision_score and recall_score are climbing too. Proving that evaluation metrics are no longer an afterthought. Oh, and check this out, Axis 3D made the list. I haven't used it much, but clearly, 3D plotting still has some loyal fans out there. But the real soul of objects? Their methods. And surprise, no surprises here. Fit, predict, read_CSV, head, filna, plot. These are practically muscle memory for any data scientist. One cool insight. Read_CSV is actually the only function among the top methods. A perfect reminder of how central it is to every Kaggle project. If Pandas had a start button, this would be it. Also interesting, methods like walk and glob showed up. Looks like more people are working directly with files and folders. especially when exploring datasets on the go. And finally, the attributes. Can we talk about how shape is still the number one? It's basically the heartbeat check for every data frame. Some other standouts. Path, history, name. Kind of poetic when you think about it. And of course, lock and iLock, no pandas notebook is complete without them. Even uint8 popped up, likely thanks to all those image-heavy CV projects. All in all, these tools may change with time, but the essentials never fade. Whether it's data shapes, accuracy scores, or just a humble read_CSV. This is what Kagglers are really using, every day. Now it's time to shine a light on the true pioneers. The Kagglers who were the first ever to use some of the most iconic tools and libraries we all rely on today. Here are the top 5 package pioneers. Ben Hamner, the first person to ever import pandas on Kaggle. I mean, talk about laying the foundation of modern data science. Witty, the one who brought in sklearn.model_selection. Without this, no train test split, no cross-validation, a true essential. K0226, the earliest user of Torch. Back when deep learning on Kaggle was still experimental, K0226 was already torching ahead. Data Canary, introduced matplotlib.pyplot. Probably the person we all owe for making plt.plot, second nature. Jeff Moser, the first to use TensorFlow. Before it was a buzzword, Jeff Moser was already writing TensorFlow code in notebooks. The next 5 pioneers? Also legends in their own right. Ruthwik Messina, Vishal Subbiah, Miniashkin, Ralston 3, and Kato Takuya, thank you for shaping the ML stack. Raising hands. Here are the top 5 function/class pioneers. Albino Cordero, first to use train_test_split. That function is basically Kaggle's rite of passage. Daradog brought a standard scaler. Probably saved millions of models from bad scaling since day one. Data Canary, again. First to use accuracy_score. Defining how we measure performance, one score at a time. Brian Knorflin, introduced confusion_matrix. We've all stared at one and gone, wait, is that FP or FN? Blazeb, the first to use classification_report. And suddenly, model evaluation looked clean and comprehensive. Wrapped up right behind them are Sarub 1331, Gustavo Damari, Michiel Kochman, Werion, and Kato Takuya. Silent starters, foundational work. Here are the top 5 method pioneers. Twila, the first to call read_CSV. Quite literally opening the door to the dataset. Christy Simmons, who used head and sum before most even knew they existed. She also made it onto the attributes list, a true method master. Data Canary, yes, again. Introduced show. Helping everyone visualize their data, right from the early days. Sarub 1331, first to use fit. The most overworked method in ML history. Phase 42, brought in join, quietly improving how we merge data. The next wave of method trailblazers includes Lilith Asia, Sami Shin, David Shin, Zichin, and Ben Hamner. Thank you for defining the way we interact with our data. Here are the top 5 attribute pioneers. Christy Simmons, again, first to use shape, columns, and lock. Basically defined how we explore and inspect data frames today. Sismanis, introduced path, the backbone of file navigation. Tumjiang, gave us values and iLock, showing us how to dive deep into the data. Sorendip, pioneered index, letting us slice and dice efficiently. Lilith Asia, used random, giving our models that beautiful touch of chaos. And of course, we can't forget Tamale, data mining 013, Renalancine, Sarub 1331, and Blazeb. Your early contributions shaped the language we now take for granted. Shout out to the OGs. While the rest of us were still Googling what is XGBoost and should I be scared? These folks were importing, fitting, scaling, and splitting their way into Kaggle history. They ran fit before it was cool. They called read_CSV, before we knew what CSV stood for. Meanwhile, I showed up fashionably late. Snacks in hand, while everyone else had already plotted their SHAP values and hit CV equals 5. So yeah, to the OGs of Kaggle. You didn't ask for the spotlight, but we're shining it on you anyway. Thank you. You'll find the full charts and names for all the pioneers mentioned and more. The notebooks they wrote in, linked in the video description. Please watch full video, then go check it out. Tag them. Celebrate them. Let them know they were first, and they made a difference. Usually, code is just code, imports, functions, methods, done. But on Kaggle, it's a bit more poetic. Over the years, the community has coded in phases, like eras in history. And if we track the top 20 packages over time, we see some wild stories unfold. Package usage over time, the rise of the OGs. Rewind to early 2018, suddenly, NumPy and pandas spike out of nowhere. It's like someone just dropped the data science cheat code. By 2020, we see Matplotlib, OS, and even Seaborn climbing the charts. Like the ecosystem itself hit puberty and came out swole. Meanwhile, packages like Tree and TQDM? Just chillin'. Steady, low-key, loyal. New kids like Polars and DuckDB? Still hustling, still grinding. But pandas? Still the GOAT, the unshakable boss of this ML dojo. The great algorithm showdown, dense versus the world. And then there's dense. The AMD of deep learning, consistent, explosive, and a bit moody. Between April 2019 and May 2021, Random Forest Classifier tried to sneak into the spotlight. Respect. That was its era of forest domination. But suddenly, boom, accuracy_score takes off. Lockdown hits. People stop flexing and start seriously coding. Silence. Focus. Code. And me? Bro, I was still lost in the forest of calculus. That's your real motivation, people just did. Head, data frame, and, what even is going on? In January 2018, Head was living its best life. All thanks to pandas and read_CSV, a match made in data heaven. But by late 2018, boom, humbled. And then, out of nowhere, Walk and Info go full SpaceX in 2019. Quiet launch, zero noise, straight to the moon. Today? Surprisingly, Drop, Join, and Even's label are more popular than Head. Is it the rise of Polars? Or did we collectively say, I'm done previewing data, let's build stuff? Attributes that mattered, a saga of data, columns, and CUDA. January 2018, the cool kids, data, columns, types. But then mid-2020, the pandemic hits. People start obsessing over iLock, lock, and every column you can describe. And this? That red rocket line? CUDA. Soars in 2019. Peaks in 2020. Dies in 2021. RIP to all the GPU dreams we once had. And then, a poetic moment. Data finally beats history. People stopped reading the past and started exploring the present. You love to see it. Era summary, a Kaggle timeline. First came the analysis era, 2018. People read CSVs, printed .head, and drew 400 Seaborn plots per notebook. Then the ML boom, 2019 to 2021. Random forests everywhere. Accuracy_score becomes a household name. The deep learning phase? Unreal. From 2020 to 2022, dense fought dense, and CUDA soared, until GPUs said no more. What followed was maturity. Kagglers started choosing drop, join, and's label like grown-ups who'd seen some things. And now? People are done with history. They want the data, the columns, the types. Not flashy, but efficient, minimal, meaningful. Final thoughts, from a fellow Kaggler. Dear Kagglers, this was beautiful. while I was still wandering the forest of calculus. Y'all were quietly mastering accuracy_score, CUDA, and join. You didn't brag. You didn't flex. You just coded. And that deserves all the respect. Work hard, bro. This community already is. Since AI has been booming, I thought, why not analyze the trend in AI itself? I'm not here just to celebrate the hype. I wanted to get into the details, the code, the classes, the rise of tools behind the curtain. So, let's begin. The Transformers era. It all kicked off between January and March 2020, a sharp spike in Transformers usage. By September 2022, things dipped, but then? January 2023 hit, and boom. Another massive surge that hasn't slowed down since. Meanwhile, libraries like OpenAI, PIFT, and sentence_transformers? They tried to keep up, but Transformers is clearly the Usain Bolt of this AI race. And by January 2025, guess who started spiking again? Yup, OpenAI. Must be Sam Altman playing chess while the rest of us are stuck in Jupyter notebooks. The tools behind the magic. That bold red line you're seeing? That's AutoTokenizer. It started getting love in January 2020, spiked again in April 2021. And since then, it's been riding high. Basically, it's in the air now. But wait, that sky blue line? That's Trainer. It was asleep from 2017 to 2019, got a little boost in 2020. And then just rocketed. Silent Hero Energy, FR. And the orange line? That's AutoModel for Causal LM. Let's just say it struggled, until 2022. Then it finally got its glow up. Oh, and that pink line? Yeah, you guessed it, Llama Tokenizer. Post-2022, it just took off like a SpaceX launch. No cap. The rise of compilation and training ops. You see that orange line creeping up in 2016? That's compile. Quiet start, but by 2020, and again after January 2022, total glow up. But the real fun begins with our 4-ops warriors. Half, train, 2, and quantize. They all started grinding around 2016. Got their breakout in 2020, and by 2022? They were everywhere. Meanwhile, other functions? Still waiting for their big break in the shadows of your cell number 3. The attributes that mattered. My eyes instantly locked onto one thing, config. Started around 2018, steady growth, then boom, mid-2020 spike. After chilling for a while, mid-2023 hit, and it was sky high again. Now for a sleeper hit, quantization_config. Quiet start, steady climb, then post-2023? That thing is blasting off. Honestly, feels like March 2024 was the tipping point. Everyone suddenly cared about efficient inference. Why? Easy. Because GPU bills started hitting harder than reality. Final thoughts, the AI awakening. Dear AI practitioners, dear Kagglers. This has been a wild, beautiful ride. While some of us were still debugging .compile, or watching .train, crash with no error. You were mastering AutoTokenizer. Configuring your transformers, and making quantize a legit verb. You didn't scream about it on Twitter. You didn't post flashy charts. You just coded. And now? You've built the future. Keep going. The chapter isn't over. Let's take a moment to honor the true adventurers of the AI age. Those brave Kagglers who used the top tools before they were cool. These are the folks who ran Transformers before it was mainstream. And typed generate, when others were still printing hello, world. Let's meet the pioneers. Kagglers who used top AI packages first. Rafael Pronko, first ever to use Transformers. This legend practically opened the gates to modern NLP on Kaggle. Linkanjarad brought diffusers into the notebook scene. Before text-to-image even had stable diffusion memes. Datarage, the first to use sentence_transformers. paving the way for semantic search and embedding-based magic. Writing, the first to run Accelerate. When speed met simplicity, this man was already ahead of the curve. Manish took the first steps with Peft. Model fine-tuning was never the same again. And joining them, Shanankov, Namakan, Halil Sada, Huikong, and Cantoni 81. For pioneering bit sandbytes, Auto_GPTQ, OpenAI, Llama_index, and TRL. All notebook links will be in the description, show them some love. Kagglers who used AI functions first. Cedric Lacrambe used Generate first, planting the seed for all those auto-replies and AI jokes we love. Qatar's Tokenize, before it was trendy. Erie long 0611, add a TikTred, with pipeline, get_scheduler, and get_cosine_schedule_ with _warmup. And Divyansh Vishwakarma, Navaid, the visual magicians with image_grid and prepare_model_for_bit_training. Kagglers who used AI methods first. We salute Astromiz for launching Generate into Kaggle history. Kmader was first to .2, a device, the original GPU whisperer. IFOS went half, while Gustavo Damari compiled models like a boss. Dienzer, Christofenkel, Hureliu, pushing to hub, prepping for Gen, and quantizing like pioneers. And props to Xiao22 and Lilithasia, who were training and backprop before it was sexy. Kagglers who used AI classes first. Meet the architects. Nage Singh, first to call AutoModel for causal LM. Kashnitsky, the OG AutoTokenizer initiator. Caveland, Linkanjarad, Tuto Devnal, early adopters of diffusion pipeline, stable diffusion pipeline, and Llama Tokenizer. And let's not forget Amersharaf, Lotfi, Usamayasur, Leo Kanila, Manish. Shaping the way we use trainer, CLIP model, autoprocessor, and more. Kagglers who used org-specific packages first. Transformers? Rafflepronko. Datasets? Dramasis. Jax? Fihipsi. OpenAI? Halil Sada. T5? Ksenia Koshkina. Fairsec, Kaggle APIs, Accelerate? The rest of the crew, already diving deep. Again, you'll find all their notebook links in the description. Don't miss them. Shout out to the trailblazers. Before we even typed import, these Kagglers were already exploring new libraries, debugging in the dark, and sharing their findings with the world. While we were asking ChatGPT what a causal LM is, they were running .compile, fine-tuning with Peft, and confidently push_to_hub, ing their masterpieces. You might not know names, but now you do. Let's celebrate them. Tag them. Thank them. And maybe next time? Your name's on this list. Stay curious. Stay inspired. And as always, keep Kaggling. Let's take a step back and look at the journey from the top. The data science timeline for Kaggle. 2018, the analysis era. Back when .head was a flex. And pandas, NumPy, and a CSV file were all you needed to feel powerful. A time when curiosity was greater than compute. 2019 to 2021, the ML boom. The age of random forest. Of accuracy_score, confusion_matrix, and every Kaggler's favorite debate. F1 score or accuracy? This was when machine learning wasn't just cool, it became a competition. 2020 to 2022, the deep learning hype. Dense versus dropout. CUDA battles. Kaggle notebooks turned into GPU-powered dream labs. TF and Torch fought for the crown, while Kagglers just kept building. 2022 onward, the pragmatic shift. Something changed. Suddenly, it was about drop, join, iLock, and clarity. People weren't just coding anymore, they were thinking like architects. Minimal, mindful, methodical. Now, the data-centric age. Less .history, more .columns. Less flex, more focus. People are building with purpose. And Kaggle notebooks have become quiet, powerful lessons in how to think. Resources. Want to dig into the data yourself? Metadata Miner Notebook. Meta Kaggle Code Dataset Miner. Dataset for mining process. Meta Kaggle Code Metadata CSV. Notebook for all these facts. Meta Kaggle Kernels Analyzer. Check the description, links are all there. Dive deep if you'd like. Credits. To the Kaggle team. To the Meta Kaggle dataset. To every coder, curator, and commenter. To the OGs, the newbies, the ones who quietly inspire. And to you, the reader. Whether you wrote 1,000 lines or just ran your first print. Thank you. Thank you so much. Thank you so much. To all Kagglers. Hey reader. Brother. Fellow Kaggler. Can I be honest? I thought this would be a short write-up, a fun stat dive. But somewhere in the middle, something changed. I wasn't just analyzing data anymore. I was uncovering a story. A story about a community. From the .head explorers of 2018 to the quantize wizards of today. You've been building a timeline that means something. Kaggle isn't just a site. It's a place where people grow, share, and inspire. Without ever needing the spotlight. To the silent coders. To the ones who hit upvote just to say nice job. To the leaderboard climbers and the helpful commenters. You didn't just make this write-up possible. You made it beautiful. So, keep building. Keep learning. Keep sharing. And one day, someone's gonna scroll through your notebook and say, "Damn, this is what got me started." With all my respect. With all my gratitude. Ayush.